Hey all, this is the Precalculus Spring Final Notes video. I'm hoping to do it all in one take, but we'll see how it goes. So the final, it is coming up in that last week of May. It is 60 minutes long. It is a 4-function calculator allowed exam, and there is a no card allowed, but we're saying no to the unit circle. And I'm saying no to unit circle because that's that number one piece of feedback I got from the current calculus students is that they didn't know the unit circle well enough. We have to have that down, have to have that memorized. It's important, but you can have we can have only other formulas on there. Okay, we can replace the lowest test score of the semester. Otherwise, it's worth 15% of your grade. And then concepts is packet of her game. Really, we're emphasizing those concepts that need to be successful in calculus, and to get more idea of the questions, you can check out the practice deltas and the practice final, which you will get shortly. There's no trick proofs or conic sections, and the best thing you can do prepare is just by watching this video, doing those delta review assignments, and completing the practice final. If you need more help, come to office hours or academic collaboration. Let's get started. So, rules of exponents. Very, very important to know. Again, should be memorized for sure. We have a to the m times a to the n is a to the m plus n. We have a to the m over a to the n is a to the m minus n. We have a to the m to the n is a to the mn. And basic ones like a to the 0 is 1, right? Also important is a to the negative m is 1 over a to the m, and 1 over a to the negative m is a to the m. So if you have a negative exponent, you can move it into either the numerator or the denominator, depending on its current location, like move it into the other part of the fraction to make it a positive exponent. Right? If it's negative in the numerator, we can move it to the denominator and make it positive. If it's negative in the denominator, we can move it to the numerator and make it positive. Okay, so when we simplify these here, we are going to get x to the third, y to the sixth, that we're multiplying over x to the negative 1, y squared. Then we're going to subtract. We're going to get x to the fourth, y to the fourth. Okay? Here we're going to multiply. We're going to get x to the 6th, y to the negative 9th. That is x to the 6th over y to the 9th. Okay? Radicals, also really important in calculus. You got to be familiar with your radicals. So the rule is x to the a over b is equal to the b root of x to the a. Okay, so x to the 3/4 would be the 4th root of x to the third, x to the negative 1/2. Well, that's the same as 1 over x to the 1/2, and that's the same as 1 over root x. The 5th root of x to the 7th would be x to the 7/5, and then 1 over the 3rd root of x to the 8th. Well, that's the same as 1 over x to the 8/3, which it would be the same as x to the negative 8/3. Okay? Those are radicals and exponents. Complex fractions. So for complex fractions, we're looking to cancel out the fractions that are existing within a bigger fraction. So to do that, you multiply by 1, but you multiply by 1 so that it's going to cancel out these denominators within the fraction. So we have a here, so that means we would multiply by a over a so that we cancel out that a, right? So a times 25 over a, that's just 25. A times negative a is negative a squared on the bottom. A times 5, 5a. A times a squared. Okay? On the right side. Again, so we want to cancel out the x and x minus 4, top and bottom. So we have to multiply by the least common denominator. So that would have to be x times x minus 4. So we're going to multiply both top and bottom by x times x minus 4. And when we do that, the first term, it's going to cancel out the x's. So we're going to have negative 2x minus 4. And then the second one, we're going to have a 3x squared. because the x minus 4s will cancel. On the bottom, nothing's going to cancel, so we're going to have 5x, x minus 4. And then here, the x minus 4 will cancel, so it'll be just a minus x. Okay? All right, that is complex fractions. Distance, midpoint. So we can use formulas or we can plot the points. Plotting the points, we see 2, 5, negative 3, 0. We see we have a triangle. So to get this distance, you're going to use Pythagorean theorem, right? And that, you guys know that. C squared, A squared, and B squared. That's essentially what the distance formula is, just rearranged. So that A, that distance A, is y2 minus y1, so 5 minus 0. We can set up this here. So 5 minus 0 squared. This B is x2 minus x1, which is 2 minus negative 3 squared. And so this comes out to root 50. And root 50 is the same as 5 root 2, right? Because it's root 25 and root 2. 5 root 2. That's your distance. Midpoint is just the average of the x and the y coordinates. So x coordinates would be negative 3 plus 2 over 2, comma, y coordinates would be 5 plus 0 over 2. So it's just negative 1/2, comma, 2.5. Okay? That is distance and midpoint. Point slope form, so important in calculus, all over the place. Y minus y1 equals m, x minus x1. I know you get a note card, but really you should have this memorized, especially for AB. Find the equation of a line that contains a point. So you need two things to write the equation of a line. You need the slope, and then you need a point. That's it. That's all you need, a slope and a point. So just to get the slope, we're going to get y2 minus y1 over x2 minus x1. So let's go ahead and do that. So this is my x1, this is my y1, this is my x2, this is my y2. So it's going to be 3 minus negative 3 over 4 minus 2. That is 6 over 2, that is 3. So my slope is 3. And then a point, I can choose either one of these. Either one is fine. So let's go ahead and just choose 2, negative 3, because it's the first one, 2, negative 3. That's all I need. That's my x1, that's my y1, that's my m, and I plug into here. So it's going to be y plus 3 equals 3x minus 2. If you were like, no, I chose the coordinate 4, 3, that's fine too. You could also have written y minus 3 equals 3x minus 4. Either of those is fine. Either is fine. Okay? You don't need both, just either. If you want to find a line that's parallel lines have the same slope. The same slope. Okay? So, that means that m2 equals m1, right? The slope of this new line is the same as the slope of the original. If it's perpendicular, it's the opposite reciprocal. So m2 equals the negative 1 over m1. So here, to find the parallel line, you have to know the slope of the original. To find the slope of this, we're going to get y alone, right? We want to get it in y equals mx plus b form, right? So we can see what that slope is. Right now we can't see it. So let's just rearrange. We're going to have 2x minus 6 equals 3y, right? I added 3y, I subtracted 6, and then we divide everything by 3. You have y equals 2/3 x minus 2. So my slope is 2/3. So that means for this equation, it's going to be y, and I have my point already right here, right? This is my x1, this is my y1. Y minus 2 equals 2/3 x plus 2. Okay. The second one's very similar, except my slope is going to be different. It's the opposite reciprocal. My slope is going to be negative 3/2 because it's the opposite reciprocal, right? So it's going to be y, again, minus 2 equals negative 3/2 x plus 2. And that's it. That is equation of a line. All right, we're on to factoring. All right, so again, everything in here is so important for next year and the future. You've got to be familiar with factoring. So important. This right here, when we are missing that middle x term, is called a difference of squares. You see this all the time, difference of squares. And what we do when we see a difference of squares, we look for two numbers they're multiplying to get the negative 9, but they're adding to get 0 because there is no middle term, and those two terms are two numbers are negative 3 and 3. So we have x plus 3 and x minus 3, right? This is the general form. A squared minus b squared is a plus b times a minus b, right? If we're subtracting, if it's two terms and we're subtracting, we can take the square root of a and the square root of b and rewrite them as the factor is a plus b times a minus b, right? That's the general rule. If your a is 1, factoring is easy. It's just two numbers that multiply to get negative 6, add to get 5. That is going to be 6 and negative 1. So it's just x plus 6 and x minus 1. Now this is where we had a hiccup in the year. If the a is not 1, the a is 2 or 3, it's not 1, you can't use this rule. You're not allowed to use this rule. You have two options. Or the Teddy method, which I still don't understand. But there's two main options. One is kind of building out the box and kind of guessing and checking to see what the factors have to be, right? You can see, okay, well, that has to be that 2x, that has to be x. And I have to have two numbers that multiply negative 6, but these two numbers have to add up to negative 1. And so you play around with that until you get it. I think it is going to have to be minus... Let's have a look here. Well, they have to multiply negative 6, so it could be 3 and 2. 3, negative 2. Oh, that's it, isn't it? That's it. So it's going to be plus 3 here and a minus 2 here. So you get a minus 4x, and then you get a 3x here, and then altogether it's 2x squared minus x minus 6. So these are my factors, and that's the kind of guess and check box method. Or you can do the ACB method. So ACB, it's like this version over here, except we do a times c in the top, so negative 12 in the top and negative 1 in the bottom. Two numbers that multiply negative 12 add to negative 1. It's going to be negative 4 and 3. Now, those are not my factors. That's how we split this up. We're going to have 2x squared minus 4x plus 3x plus 6. And then from there, we split it. So you're going to have 2x factored out, x minus 2, and then sorry, this would be a minus 6 right here, my bad. Then you factor out a 3, and then we have an x minus 2 on the right. So then we get the same answer, 2x plus 3, right, these two values here, and then x minus 2. Same value, same answer, two different ways. Be familiar with that. Okay, quadratic formula and complete the square. Quadratic formula, negative b plus or minus the square root of b squared minus 4ac over 2a. You identify a is 3, b is negative 2, c is 5. We plug it in. 2 plus or minus the square root of 4 minus 60 over 6. Scroll down here a little bit. Sorry about that. So here's the problem. 4 minus 60 is root negative 54. We can't square root negative numbers, so this is going to have to be an I. So we're going to have 2 plus or minus root 54 I over 6, and we can actually keep going a little bit because root 54 is divisible by 17. Hang on. This is divisible by 4. 54 is divisible by 4. It is hang on, 54 divided by 4 times 12, 13, is it 13? No, 54 is not divisible by 4. Negative 54. Oh, so that's my problem. Sorry, it's 4 minus 60, it's 56. That's why I was so confused. It is divisible by 4. Negative 56 is divisible by 4. That is... Sorry about that. That is 14. So it's 2 plus or minus 2 root 14i. this should be root 56i. That's negative root 56. Sorry about that. A little bit of a fumble. I was doing well up until then. All over 6. And then we can simplify this again to be 1 plus or minus root 14i over 3. Okay. Completing the square. How do you complete the square? You set your expression equal to 0. You clear the constant, add 7 to both sides. X squared minus 4x equals 7. If this was not x squared, you would want to factor out the a, but it is x squared, so we're fine. Then you're going to add b over 2 squared to both sides. And that is going to get you x squared minus 4x plus 4 equals 11. Now, by definition, that's going to make this a perfect square that then we can rewrite as x minus 2 squared equals 11. That's why we do this, right? By definition, by adding b over 2 squared, we're allowed to do this. Whoopsies. Okay. All right, there we go. And then we can square root both sides. Oh dear. X minus 2 equals plus minus root 11, and so we have x equals 2 plus root 11, and x equals 2 minus root 11. Okay? All right. Chapter 1 review. We're getting through it. We have some parent functions that we need to know. So it's important to know how functions look without... It's important to be familiar with how functions look without depending on a table or depending on a graphing calculator. And I think some of these you are familiar with, right? We have x squared, the parabola. We have x cubed, which is that kind of S shape. We have root x, which is kind of half a parabola on its side. We have cube root x, which is has similar but has that extension to the left for the negative values. We have 1 over x, which approaches infinity and 0, and then approaches negative infinity and 0. We have absolute value of x, which is that V shape. We have e to the x, which intersects 0, 1, and then 1e. We have ln x, which intersects 1, 0, and e1. And then we have sine x, which starts at 0, goes up to 1, comes back to 0, goes back. We have cosine x, which starts at 1, goes down to 0, comes back, and back up. And then we have tan x, which approaches infinity. We have a vertical asymptote, and then approaches 0 and goes up to infinity. We have another unit that we're talking about the trig functions more, but it's important to be familiar with the basic shapes and kind of key features of these functions. Saves you a lot of time. Basic transformations. So we have a times the function f of x minus b. We're saying the b should go on the inside here. This should be a c, and then plus d. And so this d is that vertical shift. The a is the vertical stretch. If the absolute value of a is greater than 1, or its shrink if the absolute value of a is less than 1. The b is horizontal shrink if absolute value of absolute value of b is greater than 1, and stretch if absolute value of b is less than 1. And then c is the horizontal shift. Okay. All right. That is chapter 1. Moving on. Inverse functions. Finding the inverse. So, find the inverse of f of x if f of x equals x minus... What is the inverse, first of all? What does that even mean? The inverse means our input is becoming the output, and the output is becoming the input. We're essentially switching x and y, right? So if you have 0, 1 is a coordinate, now 1, 0 is the coordinate of the inverse function. That's what inverse is. We're switching the x and the y. To find the inverse algebraically, you switch x and y, and you solve for y. It's pretty straightforward. So here, remember, f of x kind of represents y. So we have x equals root y minus 3 over 2. So 2x equals root y minus 3. We're going to square both sides here. We're going to get 4x squared equals y minus 3. So 4x squared plus 3 equals y. That is your inverse. Composite functions. Composite functions are functions within a function. Some basic notation for f of x plus 3. This means take x plus 3 and replace it as x in the function. So this would be 2x plus 3 squared. Okay? If it was something like f of a plus b, that means 2 times a plus b squared, right? F of g of x means take this function and replace it for the x inside f. So 2 times root x quantity squared, that's just 2x. For the domain, it's the overlap or the intersection of the domains of the composite. So the domain of 2x squared is all real numbers, but the domain of x is 0 to infinity. F over g is 2x squared over root x, and the domain of that would be 0 not inclusive to infinity, because we cannot be 0 in the denominator. When we graph piecewise functions, you want to plug in these boundary points into the associated part of the function on the left. So negative 2 goes in, we get a 4. So we have at negative 2 an open hole at 4, and then working backwards with a slope of 1 means that we're going left 1, down 1. Here, we plug in a negative 2, we also get a 4, and plug in a 2, you also get a 4, so I can go ahead and fill in those. We're going to overlap, fill that hole in there, and then at 2, we're going to have an open hole, and then we're going to sketch that parabola in between, because it's x squared. And then it's 4 from 2 and beyond, so that means we're filling in at 4, and we're just going straight over. Okay, that's piecewise, also very important. Describing a function. All right, so first of all, we're only doing interval notation. So what that means is you're either using open parentheses or using closed brackets. Open parentheses are not inclusive. They're kind of the same as the less than, equal, less than, greater than sign. Brackets are inclusive. Those have those signs in them. Infinities are always open, and we use the union as like the or for multiple intervals. Okay, so let's do it. Domain and range. So for this function, the domain is, we start at negative 4 inclusive, right, where it's a filled in hole, and we take a break at 3. So at 3, we're open, we don't include 3, then we pick up back at 3, we go until 6, we keep it open, and we pick back up at 6, and we go to infinity. That's the domain. The range, we go as low as negative 1 included, and then we go up to infinity. And there's no breaks. Even though there are breaks in the function, obviously, every single y value is included. There's no break because there's overlap between certain points. There's no break in that way. Intercept. So x-intercepts is just negative 4, 0. Right, we can see that there. And then y-intercepts 0, 1. Okay. Increasing, decreasing constant. So for these, I just use open parentheses for the intervals. I'm not going to take off points for which interval notation you use for increasing, decreasing, or constant. I just always use open. So for increasing, we're increasing from -4 to -3, and from 1 to 3. We are decreasing from -3 to -2, and from 3 to 6, and from 6 to infinity. We are constant from -2 to 1. Okay, discontinuities. Where do we have discontinuities here? Well, we have a jump at -2 and a jump at 1. We have an asymptote at 3. And then we have a whole or removable at x equals 6. Right, you can see that here, 6. Relative extrema. So we have two kinds. We have maxima, we have minima. It's a maxima is the top of a valley, minima is the bottom of a valley. Top of a mountain, bottom of the valley. Do I have any of these? I don't have any minima, but I do have a maxima right here at -3, 4. Absolute extrema. This is we don't care about it being it could be a relative extrema as well, but it really is it's just the highest point and the lowest point. Lowest point is y equals -1. We don't get any lower than that, so minimum is y equals -1. The maximum, there is no maximum because we go to infinity. So maximum, none. And behavior, basically what are we doing as we approach infinity, negative infinity? Nothing's going on as we approach negative infinity, but as we approach infinity, our y value is 2. So we see the limit as x goes to infinity of f of x equals 2. Donezo. All right, we're on some quadratics and rational functions. Okay, I think this is new material now that I didn't cover last class. Okay, so graph and quadratics. 2, quantity x minus 5 squared minus 7. This is in vertex form. So my vertex, this is going to be -5 comma +5 comma -7, which would be right here. And then if I was going to graph this, I mean, if I was asking for a rough sketch, or you were just choosing a graph from multiple choice, for example, the next good step after you got the vertex from here, right? This is f of x equals a x minus h plus k, where the vertex is h comma k. That's what we're doing here. You could just plug in like a 6. You could find f of 6 to kind of get a gist of what the sketch is going to be. So if we did f of 6, we would get 2 minus 7, which is -5. So then you would know, oh, okay, well, this is a point, and therefore this must also be a point. So it looks roughly like this. Okay, so multiple choice question. Maybe it's like which of the following graphs represents this function. Get the vertex, plug in some points. You got it. Okay. Here, if it's in standard form, we can get the vertex from -b over 2a comma f of -b over 2a. So that would be 6 over 6, which is 1. So it's going to be 1 comma, plug in a 1. We're going to get 3 minus 6 plus 2, which is -1. So 1, -1 is my vertex. I could factor this to get the zeros. We could also just plug in a 0 is also a really good idea here, which is 2, which means that 2 should also be at 2, and there we go. We have a sketch. So again, vertex and then y-intercept, just plug in f of 0, and then you should have enough to get a sketch from there. You could factor and find the zeros too. Okay. Find the equation of a quadratic whose vertex is -1, 1, and contains the point 3, -2. So, back to that equation above, f of x equals a x minus h plus k. we know the h and we know the k. So we know that it's going to be x plus 1 plus 1. We don't know the a, but we do know the y and the x. We know that 3, -2 have to be on there, so it's going to be -2 equals a, 3 plus 1 plus 1. So that's -3 equals 4a. So that means a must equal, oh, there's a square missing here. There's a square missing. That this is 3 plus 1 squared, so that's 16a, my bad. So it's a is -3 over 16. So it would be f of x equals -3 over 16 x plus 1 squared plus 1. My bad. Do not forget the square. Do not forget the square. I forgot it up here too. My bad. X minus h squared. All right. Features of rational functions. So rational functions are just functions that have one polynomial over another. So like a g of x over p of x, and these are just polynomials. They don't necessarily have to be polynomials to be rational, but for the sake of this lesson, they are polynomials. Okay. So polynomial on top, polynomial on bottom. How do you find the feature of these? Well, y-intercept is easy. Y-intercept is just f of 0, always. Y-intercept, f of 0, plug in 0, you get your y-intercept. Okay? For x-intercepts, you're going to set your numerator equal to 0. And you're going to ignore the whole. So more on that later. Vertical asymptotes, you're going to set the denominator equal to 0. And ignore holes. Horizontal asymptotes, you're going to take the limit as x goes to infinity, which you guys know, we just did that, right? And that's where you have the top heavy, bottom heavy, and the tie. We've done this already, but so when the bottom is bigger, it goes to 0. When the top is bigger, there is none. When it's a tie, like 2x squared over x squared, it is 2 over 1. It's the ratio of their coefficients. Okay, holes happen when factor or 0 appears both top bottom. So as an example, you had like x plus 3, x minus 2 over x plus 3, x minus 1. See how x plus 3 appears in both? That's a hole. So the hole is at x equals -3, and to get the y value of that hole, you cancel out the hole and plug it into what's left. So it would be -3 minus 2 over -3 minus 1, or -5 over -4. So the coordinate would be -3, 5/4. Okay? For when you're graphing, you plot all features above. Make number line and test points. So I'll do this in the next example, but here you'd have like the zeros and vertical asymptotes, and you test points to see whether it's positive or negative. Okay? Let's do some practice of that.